We're still working with two relationships on a set of axes, but this time we're going to find the point of intersection of a line graph, a linear function, and a non-linear function. Right, and the best way to have a look at this is two ways of paying taxi fares. So the first way is you pay per trip, which is 8 Rand a journey, one way, and we take 21 school days into consideration. Then the other way of doing it is you could hire a taxi. So a group of parents could get together, hire a taxi. It is a 15-seater, and you pay 3,006 Rand for the month. 15 seats includes the driver. So for a taxi, you can have 14 passengers. Okay, let's have a look at how we're going to work with that. Write down the formula to calculate the cost per student. So per trip, it is 8 Rand per journey, one way. So you need to get to school and you need to get back from school. So your cost is going to be 8 Rand times there and back, 2 trips, times 21 days. Okay. So if we work that out, it is going to cost 336 per month. There are approximately 20 working days in a month, so we've taken 21 for the days where there are 31 days in the month. Okay, for the option 2, it is going to cost a flat rate of 3,600 Rand. Right, and now what we need to look at here, the number of students per journey. Okay. So now if I make 1 journey, 2 journeys, 3 journeys, 4 journeys, it is going to cost you 336 for the month. Now it doesn't matter how many you are doing. So per journey is going to be 8 Rand, but we are looking for the month, 336. So we want to go to school every day, 336, 336, 336, 336, 336. Okay, but now for the taxi. If I have only one person going in the taxi, it will cost 3,600. Now you can get your friend to go with you. You will then share the cost and it will be 1,800 Rand. If there are 4 of us on this journey, it's going to cost each one 900 Rand. So from the previous lesson, you can see that the taxi journey is actually an inverse proportion graph. This is a constant product. What do I mean by that? Well, 1 times 3,600 is 3,600. 2 times 1,800 will give me 3,600. 4 times 900 will give me 3,600. So I can say 3,600 divided by my 8, that would give me 450 per student. I say 3,600 divided by 10 will give me 360. 3,600 divided by 12 will give me 300. If I divide by 14, I'm going to get 257 0.14. Right, now we have to draw this on the set of axes. Remember, you always have to put a heading, and the heading here would be, transport, not, okay, transport options. Remember, your top line is your independent variable, so we are going to draw, independent variable goes at the bottom, and over here we have number of students, and on this side we're going to have cost in rands. Okay, I have to put in rands because I haven't got rands next to each of these. Right, and if we have a look, remember how to get your intervals. I counted 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 intervals, and my highest fee was 3,600. So I divide 3,600 by 8, and it worked better to go in 500 Rand intervals. Right, so the first one, per journey, I have a look and I find one student, it is going to be 336 Rand. So 500, so that's 1, 2, 3, 4, 5. So this is 1, 2, 3, 336 is just is over there, and that was a constant relationship. Okay. Oh, and by the way, that should be a dotted line because I can't get half a student. So for that graph, I'm going to draw a dotted line at that value. Right, so I've plotted that graph, and this one would be per journey. And it's for the month. You have to label your graphs. The next one, I am plotting one student must pay 3,600. Right, so let's use a different color. 3,000, so one student, so I follow my line up till I get to 3,600. 3,000, 1, 2, 3, okay, 3,600 would be there. 2 students would be 1,800. So I go from my 2, go up this line until I get to, there's 1,500, 15, 16, 17, 1,800. I then go to 3 students, or I'm going to go to 4. I haven't got a value. It's going to be 900, which will be over here. If I go to 8 students, it is going to be 450. So it's over here. If I go to 10 students, it's 360. So 1, 2, 3, it's more or less there. And I go to 14, or let's go to 12, which was 300. 1, 2, 3. I would then also have to join this using a dotted line, and you can see I have my curve like that, and I would put, this is the taxi. Right, and again you can see that your lines intersect. My line didn't draw as nicely as I wanted to, but my lines, I am having a look here. That would be my break-even point. So I'm going to call it B or X or Q or R, whatever you're given. That would be my break-even point from the graph. So what does that mean? It means that if there are 10 students or 10 trips, it doesn't matter which journey or which option of transport you're going to take. So now, when is it cheaper? So up to number 10, up to 10 students, it is cheaper to go the per journey route. Thereafter, it becomes cheaper if I'm paying per taxi. Right, there's a better, I've done it more accurately. And this one, it's very difficult to see the break-even point. So per journey, per taxi. Why is the graph represented by a dotted line? Well, remember, you always ask, can I have half a student? No, most certainly not. The student would be dead if you cut them in half. So it is a dotted line because you cannot get half a student, and it is discrete data or counted data. I'm counting the number of students. It is easier to make a decision about these two options once the graph has been drawn. Right, again, I'm going to say it's between 10 and 11. So in a test, anywhere between there, if you show me your break-even point and you label it A, you will get your marks. That is the point of intersection. Right, the point of intersection, as we said, lies between 10 and 11 students. So the cost per journey, per student, okay, per journey would be, we calculated that to 336. The taxi for 10 students, you would have taken your 3,600 and divided it by 10, and that would give you 360. For 11 students, you would take your 3,600 and divide it by 11, and you would get 327,27 is what it would cost. Okay, other factors also play a role in the cost. So if you asked for purely economical, you would say for more than 11 students, it would be easier to, it would be cheaper to take the taxi. But sometimes reliability, or is the taxi reliable or not? How safe is the ride on the taxi? Do you know the driver? So there are other factors that also play a role in this. Now you need to complete exercise 4 on page 31.